Hello, my name is Shitij Kapur. I'm the Dean of the Faculty of Medicine, Dentistry and Health Sciences and an Assistant Vice Chancellor for Health at the University of Melbourne. A good morning to you. Thank you for joining us here today in the auditorium of the Peter Doherty Institute of Infection and Immunity, where researchers were the first ones outside of China to grow and importantly share the COVID-19 virus around the world. Now, you may have seen a recent video where I sat down with these leaders at the Doherty Institute to understand the public health implications of the virus. Now, that was 4 weeks ago. At that time, the disease was out there. Now, the threat is right here. So today, we want to share with you the substantial work that has gone on in the intervening weeks. You'll notice that our panelists are all sitting about 1.5 meters apart, and you wouldn't be surprised that I'm playing to an empty stadium here at the moment. It appears that we have reached a new level of disruption in life of our country and in the history of our world. Empty supermarket shelves, cancelled sporting events, airline shutdowns, school closures, and social distancing have become the daily norm. The nature of government and public response is unprecedented. We are all, understandably, very focused on the virus right now, but over time there will be more to consider and address the economic, the social, the psychological impacts and outcomes of what is happening here. Now, there is a lot going on and there is considerable information, and I am sad to say much misinformation swirling through the social and other media channels. But today we want to provide you with reliable, accurate and timely information currently at hand about the virus and the other issues relating to this crisis. So we hope to answer some of your questions, be they about personal or workplace or public impacts, but I do want to make it clear that what we offer here are our thoughts and expert opinions. This is not public health advice. As an institution and as clinicians and scientists, we continue to follow the advice of the Department of Health and Human Services, the Commonwealth's Chief Medical Officer, and the Department of Health, and also the Department of Foreign Affairs, and I trust that you will do the same. Let me now turn to our panel of esteemed colleagues and experts from the University of Melbourne and the Peter Doherty Institute, which is a joint venture between the University and the Royal Melbourne Hospital. And let me first turn to our leading infectious diseases expert, Professor Sharon Lewin. She's the inaugural director of the Peter Doherty Institute and a professor of medicine at the university. She's an infectious diseases physician and basic scientist. Now, Sharon, welcome. You are, of course, the leader of the Peter Doherty Institute. You know exactly what it takes to respond to this pandemic. What does it take, and how are we doing?
Thank you, Shitij. I'll start with what it takes to respond to any pandemic, because these are lessons that many of us know and are now applying those lessons to something totally new. And the principles are to stop transmission and prevent adverse outcomes from the infection. And those principles are what guide us in any pandemic, and they're the underlying principles of what's guiding us now. The difference is that we have a new virus. It's a new virus that is in a family of viruses that we've experienced before. So we know something about these viruses through our experience of SARS and MERS. So stopping transmission. And the third thing is that we've also know, at least over the last 12 weeks, what has worked in other countries, particularly China, other countries within Asia, and now Europe and the US. So what can block transmission? The fundamental principle is identification of cases, isolation, and then follow-up of contacts. We do this in any pandemic. And to identify cases at the moment, we need to test. We test a swab to identify the virus. And so it's test, 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 which is what the WHO is saying, and very efficient measures of isolation or quarantine and following up contacts. That's number one. And we've done that in many outbreaks before. The other way to block transmission is probably something that's much more new to all of us. We've thought about this many times, but never implemented it at this level, and that's social distancing. Or what I've heard recently, a better term, physical distancing, social connection, because social distancing is tend to think social isolation. But all these measures of social distancing, closing events, closing schools, working remotely, this is all entirely new for us in this setting.
So Sharon, thank you very much. And you said test, test, test. So that allows me to turn to our next guest, Dr. Mike Catton. He's the director of the Victorian Infectious Disease Reference Labs. That's the lab that isolated the virus. That's the lab that is doing most of the test, test, test. So Mike, this is where it all started. What has changed about the virus since then? But tell us a little bit about how testing is coming along.
Yeah, thank you, Shitij. My universe and the universe of my team has shrunk down to providing enormous amounts of testing. But there's probably 3 phases that we could break the activity into since that day when we first cultured the virus. So the first thing we were doing is delivering on the promise to share. So getting the virus into the hands of scientists and researchers around the world and into some big culture collections who could act as hubs to further provide access to the virus. Then there's been a phase through February where we've supported Australia and some of our near neighbour countries, New Zealand and other nearby countries, with diagnostic testing while we brought on stream public health laboratories in each of the states and territories in Australia. So there's been a Australian testing network of public health laboratories working now for many weeks, providing diagnostic capacity. And then the phase we're in at the moment is then further extending that within the states, and for me that's Victoria, to bring on stream hospital and community diagnostic laboratories. So it's worth thinking about that because that's the first time that's ever been done. There's a germ that was newly discovered in early January, and by early March we had not just state public health laboratories but now hospital and community laboratories with a test in their hands and provision of testing. So when we complete that, that in and of itself is an amazing achievement and a template for the future.
So Mike, just to give us a sense, how many tests have you done in Victoria?
Well, my lab, because until last week we were it, has provided 22,000 tests until the day before yesterday. So that's as many as a great many countries around the world.
Now, you know, most of us who read the newspapers would usually see the sort of, you know, medal ranking of testing, and South Korea comes up as one of the best. Now, you know, Victoria is not a country, but where would it rank if it was in that ranking?
Well, this is only our back of the envelope calculations, but by our calculation, South Korea is testing 3,600 people per million of population. Yeah. And we've provided 3,200 per million.
Already, and we're of course much earlier.
Yeah, so against a benchmark of a country that's being held up as an exemplar, I think Victoria.
We're doing very well.
We're doing
well, thank you. And a lot of that is of course because we were fortunate that this is where the Peter Doherty Institute is. Your test got a head start over other states and other countries, so thank you for that. But of course, some people turn test positive, and some of them get unwell. When they get unwell, they go into the hospital. Now, the good thing is that most of them do recover, as we are seeing around the world. And the reason they recover is that their immune system helps them. So we're very fortunate to have with ourselves Professor Dale Godfrey. He's the NHMRC Senior Principal Research Fellow. He leads immunology at the Doherty Institute. Dale, you are working to understand how our immune system is dealing with the virus, because it seems after one is infected, that's all we've got for now. So tell us a little bit about that.
Thanks, Shitij. Yeah, so this is a new virus. We really are learning how it infects us and how our body responds to it. As you correctly point out, most people recover from this virus without a major problem, and that's because our immune system is actively attacking the virus. Now, understanding how the immune system does that is a critical part for us to work out how we can then manipulate the immune system through the production of vaccines. And this is really a major goal of immunologists around the world, and there are many immunology teams working on vaccines, and some of them are at very close stages to being applied. There's phase 1 trial underway with one of the vaccines.
So let me ask you this. Your group here at the Doherty published a very important paper which tracked the development of an immune response in one of our early patients. Can you tell us something about what we learned for that development of immunity in a patient over time?
Yes, so this is the laboratory headed by Catherine Kadzierska in our department, and they were fortunate in a sense that they were able to access the samples from a patient while they were sick with COVID, and they were able to take blood samples at different time points as the disease progressed, as the virus increased and then decreased. And at each of those time points, they could monitor what was happening to the immune system and the different cell types in the immune system and get a very good idea from a case study. And it's only one person, but it's a really great start. What's happening as the virus is cleared? So the virus starts to disappear around day 7 in this patient, and that's when you see the immune system increasing, and then the immune system is maintained at a high active level, and the virus stays suppressed beyond that point. This just highlights to us which parts of the immune system correlate with viral clearance, and that's a really great way to understand.
Now you used a word, and I just want to clarify. You said virus remains suppressed. Is the virus not eliminated?
It's probably eliminated.
You're a cautious man.
It's undetectable in the swabs.
It's
from the
undetectable,
patient.
and
Yes.
that's why you're saying, okay, fair enough. Well, this gives us a very, very good sense of what happens in the virus, in the body, how we're dealing with it as a state and a country. But of course, this is much more than just an Australian phenomenon. This is probably one of the biggest things from a public health point of view that we've seen in our generation. And we're very fortunate that we have amongst us Professor Kanta Subbarao. She's the director of the WHO Collaborating Center on Influenza. Her research is focused on newly emerging viral diseases. And she is the queen of pandemics, I'd have to say. Kanta, you were there for SARS, you were there for MERS, you're there every year for influenza. Tell us how this is similar, but also tell us how this time it's different, because to us who are not experts, it does seem different, and what implications it has.
Thank you, Shitij. This is very different. It's different from influenza, and it's different from the previous zoonotic coronavirus infections that we'd seen before, SARS and MERS. So starting with the SARS outbreak, which is caused by a related coronavirus, SARS and MERS and COVID-19 have all been animal coronaviruses that cross the species barrier to cause disease in humans. What's different about this one is that although SARS and MERS cause severe respiratory disease, they didn't spread efficiently from person to person. So the ability of this virus to spread from person to person efficiently in the community is a game changer. And it makes it much more similar to the behavior of influenza viruses. And it makes it much more similar to the spread of a pandemic of influenza. So that's where the similarities lie. The difference from influenza is that it's a completely different class of viruses. We have no immunity that we know of to this virus. And so you have a completely naive population around the world. With the last pandemic of influenza in 2009, actually people born before the 1950s had some residual cross-reactive immunity, which we think is why the 2009 pandemic was not as bad as the 1918 pandemic, when the population was completely naive.
Now you said cross-reactive immunity. Can you explain what that is?
Yeah, so cross-reactive, by that I mean if you've had some prior infection by a related virus, you might have some immunity that would cross-react with the novel virus and control the virus replication, control the disease. And this happens with influenza viruses if you've had an infection caused by a related influenza virus. We've had 4 human coronaviruses. We have 4 known coronaviruses that circulate in humans that account for 5 to 8% of common colds. So they tend to cause very mild illness. We need to now study and see whether there is any cross-protection or cross-immunity. But we don't think there will be. It's possible with one of the viruses, and that's an area of active research.
Right, well, thank you very much. So we've talked about the virus, we've talked about how it's similar, how it's different. But one thing that has been very different, and maybe this is just our Western perspective, that when SARS and MERS came, it did not preoccupy our imagination or impact upon our lives this much. But this one is. Look at the way we are sitting, look at this empty hall. Life has indeed changed. Some of it has to do with the virus, some of it has to do with us. And to help us with that is Professor Sarah Wilson. She is the head of the Melbourne School of Psychological Sciences. She's an internationally recognized expert who advanced our understanding about the brain basis of human cognition and behavior. Sarah, your work can tell us a lot about human behavior. We have seen a range of human behaviors in response to this virus. Tell us what your take is on this and how we are responding at this stage of the pandemic.
Thanks, Shitij, and good morning, everyone. So you're right, the range is broad. People's responses do differ from what we've seen, some very poor responses through to very inspiring responses, which we've heard about. I think in understanding the psychological impact, what we need to know about is 3 implicit cognitive biases. We call them protective biases or positive illusions that all of us have. We're usually not aware of them, but they are, the first is that we have a general belief that we're better than average. And of course we know that can't be possible because half the bell-shaped curve has to be below average. The second bias or illusion is that we have more control over events than perhaps we probably do. And the third is the optimism bias that the future is very rosy. Now we know from a large body of psychological research that when we have a threat and it's immediate, what it does is that it challenges those implicit biases. And in some individuals, it shatters those biases and they start to feel anxious, and the fear response, which is what we've been seeing in the community, rises. Now, the other thing that we know is that just like a virus, fear is contagious. And we have an evolutionary adaptation for that. So if we think of the deer on the Serengeti plains, the first deer hears a rustle in the bush and it's a lioness creeping up. It's actually adaptive for all the other deer to take flight. And the deer that doesn't do that gets eaten. So this is a selected for response. In this case, however, that contagious fear reaction causes the types of perhaps less positive or negative behaviours that we're seeing. And our social media turns into a propaganda machine that really maintains that mass hysteria. And so what we really need is much more psychoeducation, less catastrophising and thinking of the worst possible scenario. We need to acknowledge it, but we also need to put it into perspective, put it into a broader framework. What are the, tangible contrasts? For instance, how many people have died on our road this year versus how many have died in Victoria from COVID-19? Taking that broader perspective and then using our response rather than some of these negative behaviours that we're seeing, focusing them on things that we can do, tangible things that we can do, pulling together to support each other and to fight this collectively rather than perhaps fighting each other, as we've seen images of in the supermarket.
Yes, indeed. Well, thank you very much. You did bring up of how individuals are responding. So let me just open up to the panel now and walk us through a journey of what will be happening to an individual today. So I guess it might just be a matter of time before some of us get cough and fever. And of course, the government advice is to call this central number, the COVID hotline. Sharon, what does happen when an individual with just cough and fever calls the hotline? What do they do?
Well, at the moment, the first thing that's done is to assess whether this person is at risk for COVID-19 and warrants testing. And because at the moment we're testing people who have returned from international travel in the last 2 weeks and have symptoms, or are contacts of people who have known COVID-19 in the last 2 weeks and have the person has symptoms, or they're unwell with pneumonia. They're the people that we're recommending testing, not widespread population testing of anyone with a cough or cold.
I see.
So if someone rings ahead to the hotline or to a hospital or to your general practitioner, usually there's an assessment of does this person need testing. If they do need testing and they fall into one of those 3 risk groups, first of all, if they're sick, the advice is to go to ring ahead and to attend for medical care. And the reason why the advice is to ring ahead is that we really discourage people turning up to hospitals and general practices who are potentially infectious. And so if testing is needed, the advice is to attend one of our many testing clinics that are now functioning in probably all of our public hospitals. A mask will be given to the individual prior to entry into the hospital. And then a nose swab is taken, basically what we call a nasopharyngeal swab, a test to look at whether the person is positive or not. Mike is running an incredible operation here on testing. The minute the test, when the throat swab is collected by someone who is wearing personal protective equipment.
Right.
So the person collecting the test, the nurse or practitioner, will be wearing a gown, gloves, mask, goggles. They'll collect the throat swab or nasal swab, and they'll send it off for testing whether this is COVID-19 positive or not. Now, once that test hits Mike's lab, the turnaround time, it can be as short as 3 hours. But if at the moment with so much testing, the turnaround time is longer than that at the moment in Victoria. And so while the person is waiting for the result, and if they're not unwell, they'll be told to go home and to self-isolate until the test result is available. At the moment in Australia, in Victoria, it might be 1 to 2 days.
Well, I was talking about a network of hospital labs that's been set up over the last week. That's really positive because it means you don't lose time moving the specimen through a system to get to a central spot. So I think probably from about yesterday, it's probably within the same day, right across.
That's wonderful. So
it's really important because while they're waiting for that test, you're in self-isolation. And that in itself raises anxiety, has implications for the people
Household
you're living
members.
with. But people go back home and they're given very clear guidelines
as to
how to live over that period. Now, if the test comes back negative, it's all fine.
Right.
If the test comes back positive, then they need to have medical attention. They may or may not need to come into hospital.
to the hospital. Now, just to get a sense of numbers here, 22,000 tested. How many positive in Victoria?
I have to confess, Shitij, I don't have the figure in my mind for today, but the test positivity rate has risen from about 0.2% to about 0.5%.
So that used to be
0.5%.
2 in 1,000 to now 5 in 1,000.
Correct.
So the vast majority of tests are still negative.
Still negative, correct.
So should that give us some comfort as we're walking down the street that we're just not, around people who are very infected?
Absolutely. It's at the moment, return travellers still dominate the positive tests. There's really only been a couple of examples out of all those positives where we can't link it back to a return traveller. So at this phase, it's still people coming back now from the US.
Yes. Things have changed, haven't they?
Correct.
As I said, we used to all look to China and think that's where it's happening, and now it seems that Europe and the US, and we'll come to that international perspective. I just want to stay with the individual. We took the rosy picture. They didn't have the positive test, or they went home and it all worked out well. But if it doesn't and you need to come to the hospital and now you're a known case of COVID, how would it usually work, Sharon? What sort of a ward would they come into, and how would it sort of escalate, if you may?
Well, if a known case of COVID-19, about 80% of people will have mild symptoms and could most likely be looked after at home, and they would be in stricter quarantine than the self-isolation, and there'll be regular review, and they'll be allowed to come out of isolation. The definition's changing a bit, but usually if they have 2 negative tests, then they're allowed to come out of isolation. Their immune system has kicked in, they've cleared the virus. We have no evidence that you have long-term carriage forever. The virus gets cleared, and maybe they're even immune. We can talk about that later. So that's 80%. About 20% will need to go into hospital. And at the moment in our hospitals, while our numbers are low, we would put someone in a single room, preferably with what we call negative pressure, and they're looked after with what we call barrier nursing, meaning that people that are looking after this person who's in a separate room will be wearing, again, a gown, gloves, mask, goggles while they care. We're very used to looking after people in isolation like that, similar to what we might do in...
But it's a pretty involved enterprise and quite demanding on the nursing and the hospital.
Yeah, but we're used to it. And hospitals are very used to caring for people. And in Victoria and Australia, people will get excellent care even when they're in isolation. And they will receive what we call supportive care, because we don't have any specific medications for COVID-19 currently. They receive supportive care, which means making sure their oxygen levels are appropriate, they've got fluids, they may need antibiotics if they have secondary infections. And in about 5% of people overall, so about a quarter of people that make it into hospital actually get very sick and may need intensive care. And the other interesting thing about COVID-19, different to influenza, is this happens over quite a long period. So what we've learnt from very detailed studies of thousands of people across China is that in the first week the symptoms are mild, and the second week people tend to get unwell with progressive pneumonia or lung inflammation, finding it increasingly difficult to breathe. And of those people, about a quarter of them will need to go into intensive care.
And so from the 180 sort of stay at home, get better, 20 come to the hospital, 15 of those just get better in the hospital, 5 go into the ICU. Any sense, on average, how many in the ICU do well and for how many it's terminal?
The death rate is a little bit complicated, but because of we've got multiple estimates from different parts of the world. But I'll just go back to China, where 80,000 of the 220,000 cases have been in China. So I'll go back to the figures we have from China. They are looking a little different from Italy currently in the US. But on average, 1 to 2% death. But it's important to drill down into that figure, because if you look according to age, it's very different. If you're over 80, 15% death. If you between 70 and 79, 6%. Between 60 and 69, 3%. And less than 60, less than 1%. Right. So we see this very significant adverse outcomes for the elderly, and worse outcomes for people that have a range of other illnesses, and they include high blood pressure, heart disease, diabetes and cancer. So that's why there's a real emphasis on protecting the people that have the worst outcomes, which are the elderly.
Right. So this gives us a good picture, a granular picture of what it might mean for an individual and the journey. Now, of course, one has to then prepare the entire system for this. So Kanta, I'm turning to you. The way we are doing it at the moment is people are modeling this. Now, can you tell us what modeling actually means in this context? What is this modeling business?
So there's a lot of expertise in mathematical modeling, where you start with certain assumptions based on what you already know about, say, SARS or MERS or pandemic influenza or viruses that spread in a similar fashion. And you look at, you build your model, which is, again, as I said, a mathematical model of a prediction of how this virus will spread through a community and how many people will be affected, how much of a demand there will be for healthcare and ICUs and so on, and also the effect of various control measures.
So tell us a little bit about how that is looking in general, but of course we're also interested in how is it looking for Australia when this modeling is done, with all the caveats that come with this.
Right, so the caveats are important because they're all based on certain assumptions, but we now have increasing granularity in those assumptions, so the models are getting better. The latest one that's been discussed quite a bit is by Neil Ferguson from Imperial College in the UK, and they're predicting quite a significant amount of spread and mortality and morbidity impact in the next few months, but they've also been able to model the effect of various mitigation measures, including self-isolation, including a number of different measures, closing schools and so on, and their conclusion is that a combination of several measures is better than any one alone.
Which makes sense. And can you give us a sense? I saw some of those graphs that looked like if you did nothing, and then if you did these 3 or 4 interventions, and they were all non-pharmacological interventions.
That's
they
right.
weren't giving drugs to people, and not even vaccines as yet, because
That's
they
right.
won't be here, but we'll come to that in a moment. Can you tell us how much just these non-pharmacological interventions are able to reduce?
Right, so I think each of the measures was about 10% better than the previous one, and they were all much better than doing nothing. So doing nothing, I think, is not a good idea.
Yes.
And the combinations was very dramatic, very dramatic reductions in their models.
So almost from 100, where if that's when you do nothing, I thought it was something like if you did those 4 or 5, it came down to 20.
Yes, yes.
But there was a complication.
And this is the idea of flattening the curve.
Yes. So when you bring it down from 100, so tell us about flattening. So you bring it down from 100 to 20, So clearly you save some people that month, but then what happens?
So there are two possibilities that, certainly you will have an acute benefit, that there'll be less demand on the healthcare system, people will not get as sick, not as many people will die. So there's all that immediate benefit. Yeah. And that gives us time to have specific antiviral drugs, more treatment modalities that could be evaluated in that interim. So there's that benefit. It's possible that then the virus would be driven into a more, a milder
state.
That's right. And so I think it's a great idea to use the non-pharmaceutical interventions in order to flatten the curve, protect people from the severe morbidity and mortality while we are able to assess and identify treatment strategies that might work.
Now flattening the curve is essentially buying time. Buying time till other systems come about and...
Yes, it is buying time, but it's also an absolute effect as well of reducing the demands on the healthcare system.
On the healthcare system.
And on reducing mortality and morbidity.
Now look, what will ultimately perhaps reduce the demand on the healthcare system is if we can find a vaccine.
That's right.
So Dale, let me turn to you. Tell us a little bit of how vaccine development works at this stage, and what are we doing here in Australia? What is happening here at the Doherty? What's happening in the world?
Well, vaccines have been in practice to protect us from infectious diseases for decades. They come from hundreds of years ago. The earliest vaccine type approaches to infectious disease were implemented. There are many different ways that vaccines can be made. You can have a piece of a virus, you can have an inactivated virus, you can have a related but less harmful virus, or you can even just have the DNA or the RNA from a virus that will make virus proteins in the absence of a full virus infection.
Right.
Now, normally this is done in a fairly systematic, careful way by labs around the world. In this case, there are literally hundreds of teams all concentrating their efforts on how we can make a vaccine that will be effective at reducing COVID. There are laboratories in Australia that, at University of Queensland, for example, has developed a test vaccine that is a part of the virus called the spike protein, which gives that virus its corona appearance, like a crown.
Right.
And that's thought that might be good at driving an immune response against that part of the virus. And the Doherty Institute is working with University of Queensland to test how effective that vaccine is.
Right.
My lab is working with another lab in the Doherty Institute headed by Joe Teresi, making what we call virus-like particles. These are like a shell of a virus. Right. They're not infectious, but they look just like the virus, and that should provide the immune system as a cue. It will recognize what the virus looks like and effectively creates a vaccine.
Right.
There's DNA and RNA vaccines, and one of them has gone into phase 1 trials a couple of days ago.
Okay, so let's walk us through. So you take a portion of the virus, or complete virus, or a different virus, and where do you first test it in a living organism that this will develop an immunity?
The initial stages would normally be, if there's, for example, a mouse model of the disease, you would immunize a mouse. And then you'd look for the development of different parts of the immune system responding. So you might look for antibodies against that vaccine, or T cells that might be able to kill cells that are infected with that vaccine.
So if that is positive, what happens next?
If that's positive, and if you can get enough funding to take it up to the next level, you might then move into a large animal study, monkeys, for example, and make sure that the vaccine is safe and effective enough. And under those circumstances, if you're, again, every time you go through these stages, it narrows down how many vaccines progress.
Sure, so you lose some.
You lose a lot, yes. But eventually you would go to a phase 1 clinical trial with humans.
With humans. And so just give us a sense of timeline, that under regular operating procedures, how much time would it take? And if one hastened things up under these circumstances, how much time would it take to know for sure that you have a vaccine that works?
Under regular timelines, the initial development of the vaccines usually takes place over years.
Okay.
When we are working towards trying to find a solution for something like a pandemic,
Right.
then we're talking months, typically,
Right.
to get to the point where you're at the phase 1 trial stage.
Right.
And everyone is working as fast as they can in this case.
And then once you're into phase 1, till confirmation that it works in humans, how long would that be?
Well, phase 1 is really about safety.
Safety. No, I'm saying phase 1 through phase 3.
Phase 1
confirmation.
to safety through to confirmation, that would be a matter of months.
Months.
Yes.
But now you know this vaccine works. Ideally, we'd want it for 7 billion people. What's the scale-up time? Is this the sort of thing that a factory can just turn out by millions and billions, or are there limits?
There are also, well, that also takes time when we're talking millions plus vaccines. But this is one of the things that will likely be happening. That everyone will be doing things in parallel. You have a vaccine that's starting to look good in phase 1 trials. Companies will not wait until it's been through all the phase 3 trials before they start scaling things up. They'll be taking the best candidates and they'll start to scale them up. And everything will be done as fast as possible in parallel so that you'd be ready to distribute that vaccine to people who need it initially.
Thank you. So this gives us a sense. I mean, vaccine in some sense would be the ultimate, gift if we could get there, but that will take time. On the other hand, infections are rising on this side. Certainly in the world, they're rising in numbers. And of course, testing then has a very important part. So we said that currently we have this very, algorithm that you've got traveled abroad, you've got to have done this, and then we'll test you. Why aren't we just testing everyone who has a symptom or is concerned?
Would you like me?
Yes.
At the moment, we're not testing everyone because we need the tests where they're going to have the biggest impact. So if we had a really simple test, like a pregnancy test, of course we would test everyone. But we have a test that requires laboratory expertise,
Of course.
A skilled workforce,
Yes.
and the ingredients for the test.
Yes.
And as in all areas of healthcare, we don't have unlimited resources, no matter how much money you throw at things. So we have to use the test where it's going to have the biggest impact and where you're most likely to find a positive. And at the moment in Australia, and also actually we adapt our testing algorithms based on what's happening in our outbreak. So this is our testing algorithm now. If we were beginning to see a lot of community transmission, we may change the way we're testing. But at the moment, the rationale for how we test is on the basis of most likely finding a positive. Mike mentioned at the moment 2 in 1,000, 5 in 1,000. That's a lot of tests to find a positive.
That is true. But on the other hand, there is a lot of concern.
Yeah.
And there is a comfort from knowing that this sort of sniffle or cough isn't going to turn into that. It just doesn't have implications for you. It has implications for people around you, for your family. So are we working on making tests faster and more widely available?
We are. So there's a balance to be struck. There's a sweet spot because, of course, this event's unique. Even flu pandemics are seasonal. They happen one hemisphere at a time.
Right.
This is the whole world at once.
Right.
So the world's capacity to produce the ingredients for the test that Sharon was mentioning is finite.
Yes.
And there are huge outbreaks going on in Europe and America where these things are made, and the supply chains to Australia don't guarantee us the ingredients. So in this marathon rather than the sprint, we have to be doing the testing we need to do now, but knowing we have to preserve capacity for when we're going to really need it for sick people later in the epidemic. So it's all about balance. And then as you're alluding to, it's about improving as you go and innovating to get maximum bang for what you've got. So there are strategies that we're using and developing. For example, what's called pooling. In the West Nile crisis in the US, I don't know if you remember a bird-borne mosquito-borne virus in the US that was threatening the blood supply. There was a combination of lots of patient samples by the blood banks. So that they could test them as one pooled sample with a molecular test very efficiently and guarantee donor safety with limited resources.
So all interesting strategies are being considered.
Correct.
Now, we've talked, of course, a lot about this in humans, but viruses infect animals, and I think, Kanta, you told us earlier that this could have come from animals. Tell us, at the moment, how is that human-animal interaction happening in this epidemic? Should we be worried?
So we believe that this is an animal coronavirus that crossed into humans. We don't know the exact species that it came from. We know that there are related viruses in bats, and there are related viruses in pangolins. But we don't know which animals were the immediate source of this. If the question is whether our companion animals and so on are at risk, the data suggests that that's a very, very small risk.
Okay.
So we should not be worried about it.
People should not be worried about it.
No, not at this point.
On the basis of the information.
On the basis of the information we have today, it's not a huge concern.
Now, one very fascinating thing that we are hearing, we talked about the susceptibility of the young, but it also, in some sense, speaks to immunity. That isn't the right word, but that the young aren't as much affected. So tell us a little bit about, is it that they're not showing symptoms, which of course could be a problem because then they could be carrying it around, or is it that somehow the virus just does not infect them, or do we know?
We don't really know. There's emerging information on what happens in young people. Again, going back to the China experience, out of 45,000 people with COVID-19, 2.5% were less than the age of 9. So we know that very few kids were actually diagnosed with infection. So the possibilities, probably 3 possibilities. They're not exposed, meaning that it's not in the risk group, unlikely because their parents, etc., are exposing them to the virus. They actually make a very efficient immune response and clear the virus quite quickly. That's certainly possible. It may provide us with some very good information about how to get rid of the virus quickly. Or they may have the virus but not be symptomatic and therefore are infectious but not symptomatic. And there is evidence that people can be infectious, meaning their swab tests are positive, but they're completely well. And there is evidence that happens in children. We just don't know how common that is.
Right, and of course there's talk about school closures and all of that. It's a very complex question, and we've dealt with it as a nation last week, but the answer next week might be different, who knows. What's the importance of school closures in an epidemic like this, Kanta?
So again, we can take lessons from influenza, and that's often what people do. With influenza, it's very clear that children are the ones that transmit the virus. And so there are very elegant studies that were done during flu pandemics where one community closed schools and the other didn't, and they could actually follow those communities forward in time. So with flu, it's very clear. It is less clear with the coronavirus, and because if children are infected but asymptomatic, that's important to know. But it's also important to know whether asymptomatic children spread the virus or not. The other complication with closing schools is the consequence for the rest of the community.
Of course.
So what happened in the 2009 pandemic is when the schools closed, all the kids went to the mall and hung out together. So it doesn't always work in terms of achieving what you want.
Indeed.
And then there are the knock-on effects on the parents.
Yes.
So in communities like Hong Kong, where people have domestic help, when schools close, the parents can still go to work because somebody else is looking after their children.
Right.
That would have a very different impact in Australia.
So look, we've talked about these non-pharmacological measures. On the other end, we've talked about the vaccine. Is there something in between? How about treatments for someone who comes into the hospital? What's happening in that space?
So as of last month, there were 85 registered clinical trials going on in China. In China, looking at a variety of possible interventions, specific antiviral drugs, immunomodulators, and so on. Some of those data should come out soon in the studies that they were able to enroll enough people. And we and others are looking hard at existing drugs, so repurposing drugs that are licensed for other uses. Pharmaceutical companies have libraries of compounds that they know, for instance, based on molecular structure and so on, might work. So all of those are being evaluated. And then antibody, trying to help the host cope rather than just attacking the virus. So all of those strategies are being developed. In addition, at the University of Melbourne, as is elsewhere, there's a lot of work on discovery research.
Right.
Knowing the molecular structure of the spike protein and the receptor, how can you model drugs that might
bring them together? But till then, a lot of what we are asking people is to isolate themselves. And you raised an interesting thing. We've just called it social distancing. That's not really what we mean. We mean physical distancing. And of course, we do have experience from quarantine going back a long time. And we do know the psychological distress it causes for people, particularly to be alone at a time of illness. It's quite the opposite of what we usually want to do. People come and comfort you. So Sarah, speak to us. What does that mean, that hundreds and thousands of people are being asked to go into a room and be sick alone?
Yeah, so I think that's also part of the fear that we were talking about before. And people do draw on social contact as a way of facing fears. This is a normal response. Now, I think the point to make here is that we may be physically isolated, but as Sharon said, we're not really socially isolated. And here technology is our best friend in the sense that we can stay very well connected with people online. And people find other ways to connect to each other. We are fundamentally resilient as humans. We've seen, for instance, on YouTube postings of people in Italy standing on their balconies in the evening and singing together and sharing social connection through voice, even though physically they can't be together. Right. And that's been a really powerful way of social bonding.
Yes.
That has just emerged as a natural response to the threat. But I think in terms of the isolation component, we know that people experience a sense of loneliness, that can lead to a lowering of their mood. And in individuals who are perhaps a little bit more vulnerable, we may see an increased risk of mental health problems. And it's rather fortuitous because later today our school is running a psych talk on loneliness and the impact of isolation. And so for people who are worried about that, I would really encourage you to link into that. That's going to be live and a discussion a little bit like this, but with that as the topic.
And we'll actually send a link to all of our listeners so that those who are interested, because I think this is the sort of emotional dimension of all of this. Now, there is, of course, a whole other socio-economic dimension of what is going on at the moment, and we'll leave it aside for today and perhaps return to it at some other time. But what I did want to turn to is the world at the moment. Traditionally, the 7 billion of this world have looked to America as the sort of epicenter of medicine, because that's where, the quadruple transplants used to happen. But their response to this epidemic has been a little bit wanting. How is it? They had all the advance notice. They've got probably the most advanced medical facilities in the world, some of the best scientists that there are. Kanta, you've worked there. What didn't happen this time?
That's a good question. So I think that there was a dismantling of some of the structure that would have responded to a pandemic at the policy level. There was probably some degree of feeling that it was happening elsewhere and it wouldn't be the same in the Western world. And I think, that was a problem. But I think they are now putting a lot of resources, bringing a lot of resources to bear, at least at the scientific level and medical. So I think, they will hopefully, if money is the solution, catch up fairly quickly. But there were certainly missteps.
Yeah, but and I think we can take comfort from some experiences. In China, when it started going up by thousands, we thought this could go into millions. But isn't it remarkable that that curve, it's not just flattening, it's just stopping the curve from almost 80,000 infected and almost, 4 weeks later, it's a few thousand more and that's about it. Did that surprise you?
That did, and it actually gives me great hope because South Korea is getting ahead of the problem. There are other countries that have had enormous numbers, very scary sort of upticks in cases, And so I think that's probably one of the things that gives me hope that. Yeah.
That's right. So there's hope in those curves. But of course, there are some countries who've managed their curves better. And Sharon, you've been talking about Singapore, and you've known. How was the experience in Singapore different, and what can we perhaps take away from that?
So Singapore was different to China. So let's go back to China. We saw this dramatic drop in new infections 2 weeks after there was a lockdown in Wuhan and Hubei province. So what China taught us was that extreme social distancing actually works. We're just not sure whether you have to throw the kitchen sink at it and do what China did, which is completely stop all activity.
Yes.
Very challenging economically, socially, and if anyone can do it, China can do it, and they did it incredibly. It taught us it works. Singapore, in contrast, used a different approach. They used an approach with strong leadership and early decisive moves by the government, probably almost certainly because they experienced SARS 17 years ago, so they know how much this hurts and how bad things can get. And they used a hybrid approach of incredibly efficient testing, and rigorous follow-up of their tests, quarantining, following up of contacts, with, again, measures that we don't usually use in Australia, or very punitive approaches if quarantining isn't respected, but very effective. And they have had a little bit of community transmission, which is what we're worried about here in Australia. And they're still getting cases, but they used a mix of aggressive testing, isolation, following up contacts, with some social distancing measures. So what we're all looking at with great interest is that they didn't close schools, but they did stop large gatherings very early before their cases were increasing enormously. And they did encourage online and remote working. For us in the university sector, they continued all their research throughout that area. And there's the economy, there's pictures of Singapore people in their shops going out for dinner, etc. So they used a hybrid, but a very aggressive testing and some social distance.
So on that note, I'm mindful we're sort of coming to the close. I want to end on a note of hope. So I'm going to go around to each one of you and ask you from your perspective at this time, which we have to admit is a little bit worrying to all of us. Sharon, what gives you hope? What do you see that gives you hope?
I'm going to select two things, and they're very high level. People and science gives me hope. People, because I do think communities can do extraordinary things. We rely on a community response here. I don't think we should rely on punitive responses. We should rely on an engaged community who all want to fix the problem. And we all have some power to fix the problem with these social distancing. So people, and within that I put professionals. So there's been incredible sharing of science and incredible sharing of information. And then science, of course. I've seen incredible things done in infectious diseases. And I hope we will see better diagnostics, maybe point-of-care tests, better antiviral.
Oh, I think you're taking away my... Mike,
anyway,
what gives you hope?
Science.
To extend on that, I'm fond of saying to my staff, you never waste a good crisis. So when you're pumping out more than 2,000 tests a day out of a lab that usually does 100 respiratory tests a day, you have to innovate, improve, make efficient, and everybody has to dig deep. So projecting that out onto society, what gives me hope is that Australian society, its health system, and particularly its public health system, will come out of this better than before.
Well, good on you. There.
Pandemics are frightening things. Never before in a pandemic have we had so many scientists concentrating all of their efforts with the latest, most effective technology onto the effort of stopping or slowing the pandemic. And right now, people all around the world are working at every level of this disease.
True.
I think that it'd be most unlikely if nothing works to bring this disease under some level of control.
Kanta?
For me, it's the science, of course, but also the public health measures. We are learning, and the ability to learn from one another. We should just take advantage of the advance the warning that we've had and take lessons from elsewhere. We know with SARS, and MERS, public health measures have helped.
Right.
And it looks like there are more extreme measures, but certainly measures
That we
are
can
working for this as well.
Sarah?
For me, it's the concept of recovery. If we look at the previous crises we've faced, like 9/11, the global financial crisis, we bounce back. We are resilient, and we have that capacity to be the same after this. The second is that sense of control and directing our behaviours on things that we can do to control it, hand washing, changing how we greet, changing how we interact, and then working collectively. We know when we work collectively, that gives us the best outcomes.
Well, let me add to that what gives me, I was worried you might say toilet rolls, and I thought, where are we going to go with that? But let me tell you what gives me hope. I think it is your passion, your brilliance, and thankfully your generosity that you made time for us today. I fear that we have to bring this to a close because I don't want to run over time. Now, usually one would turn to the audience and say, I'd like you to join me in an applause. I don't know what one does in a webinar to get you to applause, but wherever you are, there you go. Just so that people know that those are our wonderful recording staff. We didn't have a hidden audience here, but indeed, thank you very much. Look, to all of you out there, could I please ask you also to join your minds in thanking our wonderful and knowledgeable panelists. I apologize that we could not get to all of your questions, but if you find this useful and would like to see more such webinars as the crisis evolves and hopefully resolves, please do let us know. And if you would like to hear more, let us also know what you would like to hear more, not just the medical issues, but some of the larger issues that interest you. We have the privilege of being part of a large and comprehensive university with brilliant social scientists, with business scholars, and we'd be happy to bring those perspectives to you too. So please do write to us. It would be remiss of me not to acknowledge the very generous financial support that our research teams here at the Doherty have received in the recent weeks. Government has stepped up, business has contributed, and private contributions have provided us all that we needed to bolster and increase our efforts. In particular, I would like to acknowledge and support the Jack Ma Foundation, the A2 Milk Company, the Victorian State Government, the federal government, and the significant support of a private benefactor, and I hope you're listening to us today. This support ensures that our teams can focus on the science that they talked about, and most importantly, on a pathway to treatment and a vaccine maybe one day, and resilience. So thank you for joining us, and thank you.